Yeah, is the screen visible? Can anybody give me the answer by unmuting the mic? Is the screen clearly visible?
No, ma'am. Screen is not visible.
Screen is not visible. Presentation is not visible.
Yes, yes.
Okay, let's see. Now,
No, ma'am.
is it visible? Now, is it visible?
Yes, ma'am. Visible now.
Visible now, no? Comfortably able to read the words? Are you able to read the words comfortably? You can give me the answer by
Yes, ma'am.
unmuting your mic because okay. Fine. If any problem, no, you can unmute your mic and you can directly give the instructions if you have any problem. As I have taken my mode slideshow, so I will not be able to see. So please inform me. Okay. So good morning, all friends and my dear students. We have started our session first for power electronics for the GATE coaching for the GATE examination of 2021 of electrical engineering. Today's topics are introduction to power electronics, power semiconductor devices and triggering circuits, which is very base of power electronics. Is it clearly audible now?
Yes, ma'am.
Okay. So now what is power electronics and power electronics syllabus, which books you supposed to refer? So these are the contents of power electronics syllabus. Basic contents are related to the characteristics of various devices such as thyristor, MOSFET, IGBT. Then the various applications of power electronics like DC to DC conversion, which is called as a buck converter, boost converter, and buck boost converter. Then the second application is AC to DC controlled rectifiers, in which again you have single phase and three phase. There again you have commutation types. Then you have inverter, which is the last topic, that is single phase and three phase. Sorry. So these are the contents and the books which you supposed to refer. There are two books. First is the M.H. Rashid for beginners power electronics, and second one is Power Electronics by P.S. Bimra. Both the books are very comfortable. I will say if you are very what we can say, if you are not direct second year students, if you are regular students, because direct second year students have some base of power electronics, but if you are regular students and not studied your power electronics subject so detailed in your third year, if you are final year students, and if your third year students want to start your base of the subject very properly, you can even start with PS Bimra, which is very comfortable to understand because language is so easy. It may happen that Rashid you may difficult. Okay. Now, my question is, what is power electronics? So, the words power electronics, I'll give you basic introduction of the subject. Okay, will not be bored at all to you, though you have completed power electronics. So, anybody can give me the answer. What is power electronics? If you are final year students, you can comfortably define me. Even if you are third year students, then also you can comfortably define because you have already started the subject of power electronics. So, can anybody give me the answer? Yes, you can unmute your mic and you can give your answer. What is power electronics? Anybody? Yes. See, class should be interactive. Huh? I like interactive class. I don't like monotonous class. That is my feature. So even though answer is wrong, even though answer may have 2 3 words, will not be complete sentence. Or if you are not comfortable to give the answer in English, you can even talk in Marathi, Hindi. Language is not a barrier for me. Okay, but you give answer. That's it. Yes, Kalyani. What is power electronics? Yes, yes. Can you give the answer of this question?
Thyristor.
Huh? Yes. Okay. Thyristor is one of the device comes under power electronics. Good answer. Any other can try?
Study of different
Any?
devices.
Very good. Study of different devices. Very good. Very good. Any other? Any application? I have now given you the answer that we are going to study converter, we are going to study inverter, then we are going to study buck boost and buck boost converter. So these are also various applications. Okay. So like that, anybody know what mean converter, what mean inverter? In that perspective, can give me the answer, anyone? What is power
Dealing,
electronics?
dealing
Yes,
with
yes.
power, dealing with
Dealing with
power
power. Yes.
with
With
using
input.
semiconductor device.
Very
With
good
using
answer. Very good. Very good answer. Dealing with power by using semiconductor devices. Very good answer. At least that boy. What is your name? Good name?
Rajesh Pycraft.
Rajesh. Rajesh, very good answer. I like your answer because it gives you almost elaborative idea what is power electronics. Okay. So now let's see what is power electronics. The definition is power electronics is nothing but the subject deals with it deals with conversion of electric power. The conversion of electric power we are going to handle by application of solid state electronics. Now what means solid state electronics? Solid state electronics is nothing but your power semiconductor devices. Now these power semiconductor devices, why they call solid state electronics? Because they do not have any movement. The way in electrical engineering we have motor, so it is movable device. But in electronics, we have very transistors, diodes, and all other devices which are steady state. They are not moving. So these devices are called as solid state devices. For what purpose we are using them? We are using the first purpose is conversion of electrical power. And how we are going to do that? By using flexible control of electrical power for various applications by wave shaping of voltage, current, or both by using fast switching power semiconductor devices. It means we are going to change the wave shape of voltage as well as current. Now changing the wave shape of voltage and current means what? We all know that we are using AC supply from our wall board. Wall board means घरात येणारा board. आपल्या घरामध्ये AC supply असतो. So that shape of AC waveform is sinusoidal. And if I want to convert that sinusoidal into DC, from a sinusoidal shape, we are moving to a straight line. It means what we are going to change, we are going to change the shape of that waveform. It means we are going to change the form of that signal. AC signal, we are going to convert into DC signal. So that is the meaning of the sentence that we are going to change the form of the signal, and that changing the signal form is nothing but a conversion of power. If I'm changing the signal from AC type to DC, it means we are changing the power from AC to DC. Is it comfortable to all?
Yes, ma'am.
Okay. Now we will move towards the next section. What are the basic sections of power electronics? The power electronics is based in 3 sections. First is power, the way Rajesh has given the answer, it is dealing with power. Then power semiconductor devices, that comes under electronics part. And the third part comes under control part. Now what is control part? What is electronics part and what is power part? In short, I'll tell you why power deals with power electronics. Because power electronics field is ultimately controlling your transformer, your motor, which are going to handle the power in a very large amount. If you will go to electronics lab, your power supply will give you only 30 volt 1 ampere. Okay, it's a very small box. But if you will come to electrical lab, your supply is 230 volt single phase, 440 volt three phase. So as the power handling capacity is very large in electrical engineering field, the devices which I supposed to use should be able to handle that power in a large capacity. So those semiconductor devices are called as the power semiconductor devices. So the machines which are coming under electrical engineering comes under power, which are static as well as rotating. Why static? Because transformer. Why rotating? Because motor. Then electronics. What is electronics? I said power semiconductor devices which are stationary, which are solid. So these are called as the solid state devices. And control. What means control? See, under the control field, no, there are many branches involved. First control, you can use your subject FMMM and AML, like microcontroller. So you can use your microcontrollers to control the on and off operation of your power semiconductor devices. First logic. Second, you can use gate signals in the pure electronic field. You can use your analog circuit. You have studied op-amp. Okay. So you can use your analog circuits to control that on and off switching. Another field is signals and system. Sridhar sir, Raghunde sir may have taken your signals and system. Okay, as you do not have the subject, but signals and system is also one of the area which is used to control the on and off switching of the devices. And the other one area is your programming. You can use C language or Python language also to control your power semiconductor devices. So these are all fields of control where we can control the signals which are going to process the operation and which are going to control the operation of power electronics. So basically power electronics is having three streams. First is power, second is electronics, and third is control. Okay. So now, as I said that, first of all, the base is what power. See, as an electrical engineer, when I want to design my system, first of all, I am going to design my system for what purpose I am going to use that device. Okay. So my output oriented devices are important for me as a design engineer. So in the same way, no, I'll start with the first gate numerical, which is very basic in electrical engineering, and you can easily understand that gate numerical, and it is interesting also. So we can start with the easy one. If anybody has already solved that numerical, can give me the answer also. So the numerical is the line currents of a three-phase four-wire system are square waves with amplitude of 100 ampere. These three currents are phase shifted by 120 degree with respect to each other. The RMS value of neutral current is. So they have given four options: 100 by root 3, 0 ampere, 100 ampere, 300 ampere. Okay. Is anyone know the answer? If yes, you can give the answer. If no, you can say no. Then we can start the explanation. Yes. If anybody knows the answer, can directly give me the answer. If anybody knows, sorry, if no one knows, can give me, we can start the discussion of that particular question. Yes. Am I audible? Hello, students.
Yes, ma'am. We don't know answer.
Acha, you don't know. Okay, fine. But give me the answer no very fast. If you do not know the answers, na, then also don't shy, don't embarrass. Okay. Give me the answer. Otherwise, no, I have a big doubt in my mind that whether I am audible or not to you. Okay. If you do not know the answers, do not have any embarrassing feeling. Here I am to coach you only. Okay, here do not have that session that you will give me all the answers. Obviously, you do not know the subject. That's why here we are taking the session. Okay, so now let's see. The first sentence is important. The line currents of three-phase four-wire system. Three-phase four-wire system gives you which kind of idea in your mind that it is a three-phase system. Will have three terminals. Will carry three different currents in each terminal like R, Y, B. And the current flow through these three wires R, Y, B is having the amplitude of 100 and having the shape or having the form or having the type is square. Okay, so let's have the first phase current. The first phase current, say A phase. Okay, normally we are taking RYB, but in other books, no, if you will refer foreign authors, they'll say ABC. Okay, so gate paper is also in this terminology only ABC. You will not find any question related to RYB. Okay, so the A phase is having the current of 100 ampere of a square shape. So see, positive half cycle, positive square waveform, negative half cycle, negative square waveform, and the magnitude is 100. Now we all know that every half cycle is of 180 degree. Okay, so see three parts we have taken. First part, second part, and third part of each half cycle. What is the duration of total half cycle? 180 degree. So now tell me what is the duration of one single part of this half cycle? Yes, half cycle is of 180 degree. That half cycle we are going to divide into three parts. So what will be the duration of each part?
60, ma'am.
Yes, very good. 60 degree. So obviously the duration of two part will be 120 degree. Is it so? So this much duration is 120 degree. From 0 to 2 pi by 3, the duration is 120 degree. It means now, if I want to start the second current, say IB. So obviously IB will start from 2 pi by 3 because the phase shifted by 120 degree with respect to each other. So what is my IB? Let's see. IB has started from 2 pi by 3. Again, it will have its positive half cycle and will have its negative half cycle over here, one part and other two parts over here. Is it clearly what we can say? Are you understanding this? What I want to say?
Yes, ma'am.
Okay. So now we want to take the third waveform. Now obviously, see, we know that second phase is 120 degree apart with respect to first phase. Now third phase, that is IC. IC will obviously start after 120 degree with respect to second phase. It means now this is the start of IB, that is 2 pi by 3. My start of B phase is 2 pi by 3. So obviously my IC will start after 120 degree with respect to B start. So where will have the C current starting? Can be anybody give me the answer? C current will start at which instant? Positive half cycle. C current positive half cycle will start at which time instant? Yes.
120 after 120 to 180.
Yes, after 120 degree with respect to B, but there are time instants I have given. Pi by 3, 2 pi by 3,
2
pi,
pi
4
by
pi.
3. 2 pi by 3.
But 2 pi by 3 already we have taken for B. See, B is starting at 2 pi by 3. Okay. मग बी चा करंट जर इथे 2 पाय बाय 3 ला स्टार्ट होतो तर सी ह्याच्या नंतर 120 डिग्रीने स्टार्ट होईल ना बीच्या 120 डिग्री नंतर स्टार्ट होईल
4
सो
pi
सी
by
विल
3.
स्टार्ट येस सी विल स्टार्ट ॲट 4 पाय बाय 3 इज इट सी हियर सी करंट इज गोइंग टू स्टार्ट ॲट 4 पाय बाय 3 इज इट क्लिअरली getting it everyone how we have taken the waveforms ia started at t equal to 0 or omega t equal to 0. Then B has taken after 120 degree. Then C has taken after 120 degree with respect to B. So these are my three waveforms of IA, IB and IC. Is everyone comfortable to understand what I want to explain? Yes or no? Yes or no? Please give
Yes,
me
ma'am.
reply. Yes, ma'am. Okay. So now we want to take neutral current. because they ask the questions RMS value of neutral current is. Now neutral current is nothing but what? Neutral is the addition of what? Neutral is the current. Neutral, at neutral point. V electrical engineer defines what? In an ideal condition, neutral current should not have any current. IN should be equal to 0. Why I am getting IN equal to 0? Because the three phase currents, R, Y, B currents or A, B, C currents, they are exactly equal in magnitude and 120-degree apart each other with phase shift. So when I am adding them, their phasor addition equals to 0. In an ideal condition, the phasor addition comes to equal to 0. But in practical condition, what is neutral current? Neutral current is the summation of all phase current, that is IA, IB and IC. So what is IN? IN is IA plus IB plus IC. IN equal to IA plus IB plus IC. It means to find neutral current. What I supposed to do? I supposed to add all three currents A, B and C. Okay. So now let's see the duration 0 to pi by 3. First period 0 to pi by 3. In 0 to pi by 3, what is IA? 100. What is IB? Minus 100. And what is IC? Plus 100. So in 0 to pi by 3, in the first period, in the first duration, when I'll add these three currents, IA plus IB plus IC, what will be my figures? 100 minus 100 plus 100. Is it so? So what is the total current I am getting as an IN in the first period of 0 to pi by 3? Give the answer. 0 to pi by 3. What will be my IN? Yes. 100. IA is 100. IB is minus 100. So 100 minus 100 will cancel. And IC is 100. So in the first period, what will be the addition of all three figures? 100 minus 100 plus 100. What is the answer, IN?
100.
Yes, very good. 100. So in 0 to pi by 3, I am getting 100. Okay. See, in 0 to pi by 3, I am getting neutral current as positive 100. With the same logic, in the next period, that is pi by 3 to pi by 3, I am getting IN minus 100. Why minus 100? Let's see. In the next period, IA is plus 100. IB is again minus 100. So 100 positive will be cancelled with minus 100. And IC is minus 100. So what are the figures I have for IN? 100 minus 100 minus 100. So 100 minus 100 will cancel and total answer will be what? Minus 100. So next period is minus 100. So like that we plot the waveform of neutral current. Now see the third period, I will explain. Again 100 plus 100 minus 100. So 100 plus 100, first two figures I will get 200. 200 minus 100, again I will get positive 100. So we are getting the neutral current waveform of a square type with its one positive half cycle of 100 and another positive half cycle is of minus 100. And every positive half cycle, see the duration is only 60 degree. So after every 60 degree, it is changing its polarity. Fine? Okay? And as it is a square waveform, they have asked us the RMS value. Okay, so RMS value is coming now 100 ampere. How RMS value I got 100 ampere? It's a very simple logic. See, it is a square waveform. Square waveform when we have, if I want to find out RMS, what are the steps? First I'll take square. Okay, then I'll take mean and then I'll take RMS. Any square waveform, no, in short, a click idea. म्हणजे मी तुम्हाला एक शॉर्टकट सांगते की आरएमएस जर कुठल्याही स्क्वेअर वेव्हफॉर्मचा जर तुम्हाला काढायचं असेल तर एकदम सिंपल आहे. कुठल्याही नंबरचा मी जर स्क्वेअर केला, समजा मी 100चा स्क्वेअर केला आणि त्याच 100च्या स्क्वेअरचा जर मी रूट काढला तर स्क्वेअर अँड रूट विल बी कॅन्सल विथ इच अदर. And what will be my answer? The same number. 100 square in bracket is under root. So what will be my answer? 100. So the RMS of IN is coming as what? 100 ampere. So RMS value of that answer is 100 ampere because it is, see, throughout it is constant. In that particular period, throughout it is constant. So it is a DC value. DC value ची RMS value तीच असते. का? कारण DC व्हॅल्यू हा त्या पर्टिक्युलर पिरियड मध्ये कॉन्स्टंट असतो. मग त्या पर्टिक्युलर पिरियड मध्ये जर ती व्हॅल्यू कॉन्स्टंट असेल आणि जर मी तिचं स्क्वेअर केलं आणि परत मी तिला रूट केलं तर रूट आणि स्क्वेअर हा एकमेकांबरोबर कॅन्सल होणार. सो इट्स DC value will be nothing but it's your RMS value. So the answer is coming 100 ampere and the answer is C. Is that first question comfortable for all? Yes?
Yes,
Are you
ma'am.
comfortable? Yes. Okay, fine. Okay, fine. See, you are using chat box. Okay, fine for me, but no, to see that chat box, no, I have to exit from presentation mode. Okay, so I have already given you the freedom that without using chat box, no, you can directly unmute your mic and you can give me the reply. Will be shortcut to me to listen your answers. Okay, because always coming out from the presentation mode and seeing your chat will be difficult for me. Okay, and it will be another way, to listen your voice because I am totally unknown to you. So at least in that point of view, I'll listen you and we will have introduction with each other at least through audio mode. Okay, so now we will start with the second question. Is that screen visible now again clearly?
Yes, ma'am.
Yes, ma'am.
Okay, fine, very good. Now the second topic is power semiconductor devices. Okay. So power semiconductor devices, that is the second block of power electrons. I said first block was power. So we have did one question. Second block box is power semiconductor devices. Now see here also many questions comes in objective type and all questions are very basic and having some common sense. See, if you are clearly understood the fundamental part of the devices, you can easily attempt those questions. So which devices you supposed to know in power electronics? The first device is diode. Second device is thyristor. Third device is BJT, which is having two types, PNP and NPN. So NPN is not pointing inward, that is outward arrow, and PNP is pointing inward, which is having emitter arrow inward. Okay. So next device is MOSFET and the last device is IGBT. So I'm not going to teach you the characteristics or the construction part, but basic which I required to solve the questions, that obviously I'll cover up through the questions. Okay. So the first device is diode. Obviously it is a unidirectional device. Why unidirectional? Because it can carry the current only from anode to cathode, having only two layers. One is p type, another one is n type. Then the second device is thyristor. It is also a unidirectional device having three terminals, anode, cathode, and gate, having four layers P and PN. Okay. Both are unidirectional devices. They carry the current only from anode to cathode. But then what is the difference between diode and thyristor? Yes, can anyone give me the answer? What is the difference between diode and thyristor? Diode and thyristor. Yes,
Gate
unmute.
terminal.
Gate terminal. Yes. What is the use of gate terminal, Rajesh?
Control.
Controlling.
Yes, very good, very good. Controlling purpose. So diode is uncontrolled device, right? And SCR is a controlled device. Okay. Now it comes to the BJT part. The BJT part is having two types. One is PNP, another one is NPN. So PNP and NPN having three terminals: base, collector, and emitter. Now it is having low input impedance, but the collector emitter current capacity is very large in the transistor. And then the second last device is MOSFET, which is coming under FET family, field effect transistor. Okay. It is also having three terminals: gate, drain, and source. it is having some insulated gate type. Okay, here we have SiO2 layer. So its impedance is very high. Because gate is insulated, see here line is connected. See, सगळ्यांचे बघा गेट चिकटलेले आहे, बेस चिकटलेला आहे, इथे पण बेस चिकटलेला आहे, पण इथे मात्र गेट चिकटलेला नाहीये. म्हणजेच गेटच्या मध्ये काहीतरी असा लेअर आहे ज्याला इन्सुलेशन लेअर म्हणतात आणि ज्याच्यामुळे ह्याचा इनपुट इम्पिडन्स जास्त आहे. म्हणून ऑलवेज मॉस्फेटला ना इम्पिडन्स ऑफ गेट इनपुट इज व्हेरी व्हेरी हाय. And because of that gate input impedance is very high, it is very favorable or it is very useful in all applications. Okay, the similar feature of MOSFET we have used for IGBT also. So IGBT is the combination of BJT and MOSFET. म्हणून तो अर्धा MOSFET आणि अर्धा BJT आणि असा डिव्हाइसला आपण IGBT म्हणतो. म्हणून IGBTचं नाव आहे इन्सुलेटेड गेट बायपोलार ट्रान्झिस्टर आणि मॉस्फेटचं नाव आहे मेटल ऑक्साइड सल्फेट फील्ड इफेक्ट ट्रान्झिस्टर. मेटल ऑक्साइड का, कारण इथे SiO2 लेअर आहे, सिलिकॉन ऑक्साइड आहे म्हणून मेटल ऑक्साइड. ओके, so IGBT is very favorable even than MOSFET because IGBT ने काय काय घेतलं, IGBT ने BJT चे सगळे पॉझिटिव्ह पॉइंट घेतलेत आणि MOSFET चे पॉझिटिव्ह पॉइंट घेतले. So compared to all devices, no, IGBT is very favorite device in power electronics because it is having very high performance in all respect, in handling capacity of power, protection and reliability in all way. Okay, so now moving to the basic part, we will discuss the question and similarly we will discuss the fundamental part of that respective device. Okay, so the first question, 2018, it comes for 1 mark. 4 power semiconductor devices are shown in figure along with their relevant terminals. These devices that can carry DC current continuously in the direction shown when gate is appropriately connected. म्हणजे आपल्याला असे डिव्हाइसेस शोधायचे आहे की जे दिलेल्या डायरेक्शन मध्ये करंट कॅरी करू शकतात, अज्युमिंग की त्यांचे गेट ऑलरेडी अप्रोप्रिएटली कनेक्टेड आहे. ओके, आता या सिच्युएशन मध्ये त्यांनी ऑलरेडी सांगितले की हा थायरिस्टर आहे, हा ट्रायॅक आहे, हा जीटीओ आहे आणि हा मॉस्फेट आहे. सो फर्स्ट इज थायरिस्टर, सेकंड इज ट्रायॅक, थर्ड इज जीटीओ and fourth is MOSFET. And they have given the combination A option triac, B triac and MOSFET, C triac and GTO, and D thyristor and triac. So what is your guess? Can anybody give the answer? Guessing. I am telling guessing. Okay, though it is a wrong guess. Is anyone will have or will take a chance to guess the answer? I said though it is a wrong, no, I am happy. I just want to interact with you. Yes? Can we have?
Ma'am,
Yes. Yes, Rajesh, which
Triac.
answer?
Triac only.
Triac only. Okay, triac only. Good attempt. 50% correct answer. Triac only. 50%, one more device is there. Now I have given the 50% it. Is anyone other can try? I said 50% correct. It means you have another 3 options because in all other 3 options, triac is there. Triac is one device.
MOSFET and triac.
MOSFET and triac. Very good answer. Who is that fellow? Yes, your good name, please.
Govind Tapse.
Govind. Very good answer, Govind. Okay. Why triac and MOSFET? I'll give you the explanation, though he know the answer. Okay. Why triac and MOSFET? See, why not thyristor and GTO? Because see, thyristor and GTO are looking like a diode, and I said diode type or this arrow type structure. See, both thyristor and GTO are having arrow type structure. So this arrow type structure is having the terminal anode and cathode. So this arrow indicates what? This arrow indicates what? The current can only flow in thyristor and in GTO from which terminal to which terminal? From anode to cathode. So thyristor is also a unidirectional device which can only take a current only from anode to cathode. But in the figure they are asking cathode to anode. So obviously this device cannot carry the current from cathode to anode because it is not able to take the reverse current. Similar logic for GTO also. In GTO also they have shown the current from cathode to anode. So in GTO also the current cannot flow in the reverse direction because it is also unidirectional device. So obviously, if the thyristor and GTO are not the option, what will be the answer? The answer is triac and MOSFET. Everybody understood the logic? Yes? Comfortably understood?
Yes, ma'am.
Okay, very good.
Yes.
Okay. So now we will take the another question. For the power semiconductor devices, IGBT, MOSFET, diode and thyristor, which one of the following statement is true? All the four are majority carrier devices. First option. Second option, all the four are minority carrier devices. Third option, IGBT and MOSFET are majority carrier devices, where diode and thyristor are minority carrier devices. And fourth option, MOSFET is majority carrier devices, whereas IGBT, diode and thyristor are minority carrier devices. Still, I'll ask again to you. Can anyone try this? Yes. Yes, Rajesh, Govind, Kalyani, others. Anyone can try. I'm telling to guess it, nothing else. Yes? Okay. You first of all give me the answer of my simple question. Do you know majority carriers and minority carriers? Then we will ask solve this question. First of all, tell me, do you know the concept of majority carrier and minority carrier? If yes, then we will go ahead. If not, then at least let me explain that concept. What to do? Yes. Do you know the concept? Majority and minority carrier.
No, ma'am.
No. Okay, fine. Very good. Okay, now what is majority carrier and what is minority carrier? See, here, I'll give you the diagram figure. See, now I'll take the example of a diode. Okay, diode is having two layers. One is P-type layer, another one is N-type layer. Okay, in P-type layer, what we expect, P means positive. It means P layer is a positive layer. In that positive layer, what I'm expecting holes, because holes give me positive polarity. Is it so? So in an ideal condition, what I'm expecting, की suppose इथे या P layer मध्ये 100 holes present आहे. And in an ideal condition, what I'm expecting, here in this N layer, I'm getting negative polarity because I have 100 electrons are present. Okay, so when holes are present, it is give me positive polarity. When electrons are present, it gives me negative polarity. Now, हे केव्हा possible आहे? In an ideal condition. In an ideal condition, आपण जेव्हा वेफर कट करतो P टाइपचा आणि N टाइपचा आणि जॉईन करतो, तेव्हा मला एक डायोड मिळतो. पण in a practical situation, it doesn't happen. When I'm talking, it's a P-type layer, no? Because of practical impurity. आपल्याला माहिती आहे सेमीकंडक्टर हा करंट घेऊ शकत नाही, म्हणून आपण त्याच्यामध्ये इम्प्युरिटी ऍड करतो मुद्दाम. आणि त्या इम्प्युरिटी ऍड केल्यामुळे आपल्याला डिफ्युजन प्रोसेस कॅरी करावी लागते. आणि त्या डिफ्युजन प्रोसेसमुळे काय होतं की सम इलेक्ट्रॉन्स आय एम गेटिंग इन पी लेअर अँड इन एन लेअर सम होल्स आय एम गेटिंग. म्हणजे इलेक्ट्रॉन्स मला पी लेअर मध्ये मिळतात ते ऍक्च्युअली अनडिझायरेबल आहे ना. म्हणजे आयडियल मध्ये मला इलेक्ट्रॉन्स पी मध्ये नकोच आहेत, पण अशी काही प्रॅक्टिकल सिच्युएशन असते की मी ते अवॉइड नाही करू शकत, मला त्यांना एक्सेप्ट करावंच लागतं. मग पी लेअर मध्ये आता दोन्ही कॅरियर आहेत प्रेझेंट, होल पण आहे आणि इलेक्ट्रॉन पण आहे. मग पी लेअर मध्ये मेजॉरिटी कोणाची आहे? होल्सची. आणि मायनॉरिटी कोणाची आहे? इलेक्ट्रॉन्सची. म्हणून पी लेअर मध्ये मेजॉरिटी कॅरियर कोणाला म्हणणार? होल्सला. आणि मायनॉरिटी कॅरियर कोणाला म्हणणार? इलेक्ट्रॉन्सला. हा कन्सेप्ट कळला सगळ्यांना? इन पी लेअर मेजॉरिटी कॅरियर्स आर होल्स and electrons are minority carriers. मग सगळ्या पॉवर सेमीकंडक्टर डिव्हाइसेस मध्ये हे मेजॉरिटी कॅरियर आणि मायनॉरिटी कॅरियर प्रेझेंट असतात प्रत्येक लेअर मध्ये. इव्हन एससीआर मध्ये पण आहे मेजॉरिटी कॅरियर आणि मायनॉरिटी कॅरियर. जिथे जिथे तुम्ही वेफर जॉईन करता एकमेकांना, जिथे जिथे तुम्ही लेअर जॉईन करता पी लेअर आणि एन लेअर, तिथे तिथे तुम्हाला मेजॉरिटी कॅरियर आणि मायनॉरिटी कॅरियर मिळतात प्रत्येक लेअर मध्ये. ओके, आता तो लेअरची पोलॅरिटी डिसाइड करते की मेजॉरिटी काय असणार आणि मायनॉरिटी काय असणार. जर एन लेअर असेल तर ऑब्व्हियसली मेजॉरिटी इलेक्ट्रॉन्स असणार आणि मायनॉरिटी होल असणार. ओके, हा कन्सेप्ट कळला सगळ्यांना? हो का नाही?
Yes, ma'am.
हा, ओके. आता क्वेश्चन काय आपल्याला की असे कोणते डिव्हाइसेस आहेत आयजीबीटी, मॉस्फेट, डायोड आणि थायरिस्टर जे की आपल्याला उत्तराप्रमाणे बघायचंय की मायनॉरिटी वाले कोण आहेत आणि मेजॉरिटी वाले कोण आहेत. आता त्याच्यात असा कन्सेप्ट आहे की आय सेड मॉस्फेट बिलॉंग्स टू विच फॅमिली? मॉस्फेट बिलॉंग्स टू फेट फॅमिली. आता फेट फॅमिली म्हणजे काय? तर इथे स्पेलिंग चुकलंय ना, EFT झालंय ते FET पाहिजे. ओके, सो मॉस्फेट बिलॉंग्स टू फेट फॅमिली आणि फेट फॅमिलीला युजेटी म्हणतात. युजेटी म्हणजेच काय? कारण युजेटी ऑल्सो बिलॉंग्स टू फेट फॅमिली. मग यांची प्रॉपर्टी काय किंवा यांचे युनिक फीचर काय आहे? ऍज मॉस्फेट इज बिलॉंग्स टू फेट फॅमिली, द फेट फॅमिली युनिक फीचर इज दे आर युनिपोलार जंक्शन डिव्हाइस. युनिपोलार जंक्शन डिव्हाइस म्हणून त्याला युजेटी म्हणतात. Whereas BJT is bipolar junction device. आता युनिपोलार आणि बायपोलार म्हणजे काय? तर युनिपोलार junction device means those devices carries the current only for majority carriers. म्हणून त्याला युनी म्हणजे वन. मग युनिपोलार devices carries the current because of only one carrier, that is majority carrier. They don't carry the current because of minority carriers. They don't carry any current because of minority carrier. पण जे बायपोलर फॅमिली मधले असतात, जसं की हा आयजीबीटी आहे, थायरिस्टर आहे आणि डायोड आहे, हे सगळे बायपोलर फॅमिली मध्ये येतात की ज्या डिव्हाइसेस मध्ये दोन्हीही कॅरियर्स रोल प्ले करतात, मेजॉरिटी पण आणि मायनॉरिटी पण. म्हणून आन्सर काय आहे की लास्ट आन्सर आहे. आन्सर इज व्हॉट? MOSFET is only majority carrier device, whereas IGBT, diode and thyristor are minority carrier devices. फर्स्ट आन्सर येऊ नाही शकत, ऑल फोर आर मेजॉरिटी कॅरियर डिव्हाइसेस, कारण IGBT, डायोड आणि थायरिस्टर मायनॉरिटी कॅरियरचा पण करंट घेतात. सेकंड पण येऊ नाही शकत कारण सेकंड मध्ये मॉस्फेट आहे की जो मायनॉरिटी कॅरियर मध्ये येत नाही. थर्ड पण येऊ शकत नाही कारण IGBT आणि मॉस्फेट मेजॉरिटी आहे, कारण IGBT मायनॉरिटी कॅरियरचा पण करंट घेतो. म्हणून लास्ट आन्सर आलं की मॉस्फेट इज मेजॉरिटी कॅरियर अँड IGBT, डायोड अँड थायरिस्टर दे आर मायनॉरिटी कॅरियर डिव्हाइसेस, कारण त्यांच्यामध्ये मायनॉरिटी कॅरियर करंट फ्लो होतो. म्हणून डायोडची कॅरेक्टरिस्टिक बघा तुम्ही, रिव्हर्स बायस मध्ये तुम्ही जेव्हा घेत जाता तेव्हा छोटासा करंट फ्लो होतो, आपण त्याला म्हणतो रिव्हर्स सॅच्युरेशन करंट किंवा लिकेज करंट म्हणतो आपण त्याला. तर तो लिकेज करंट म्हणजे आपण त्याला लिकेज का म्हणतो? कारण तो नकोय पण स्टील तो येतो, म्हणूनच तो लिकेज आहे. आयडियल कंडिशन मध्ये लिकेज नसतंच, पण प्रॅक्टिकल मध्ये लिकेज आहे ना. मग तो लिकेज करंट कोणामुळे येतो? तर तो लिकेज करंट मायनॉरिटी कॅरियर करंट म्हणून, आणि म्हणून ते मायनॉरिटी कॅरियर डिव्हाइसेस आहे. कळली ही कन्सेप्ट सगळ्यांना? इज एव्हरीवन कम्फर्टेबल?
Yes, ma'am.
Okay, so MOSFET is majority carrier devices and IGBT, diode and thyristors are minority carrier devices. Okay, now next question. This is numerical based. Do you have calculator in your hand or you can do the calculation with your calci or mobile? सगळ्यांना कम्फर्टेबल आहे का? कारण मी तुम्हाला आन्सर डिक्टेट करणार बाळांनो, पण तुम्ही जर कॅल्क्युलेट केलं ना तर तुम्हाला ती कन्सेप्ट पण क्लिअर होईल त्या मोमेंटला लगेच. जर तुम्ही माझ्याबरोबर कॅल्क्युलेशन केलं, छोटेशा कॅल्क्युलेशन पण ते तुम्ही करायला पाहिजे, कारण मी आता ही तिथे प्रत्येक स्लाइडला दिलेली आहे आणि मी रेकॉर्डिंग पण देणार तुम्हाला क्लासमध्ये गेटच्या. पण जर तुम्ही माझ्याबरोबर कॅल्क्युलेशन कराल तर यू विल अंडरस्टँड की तुम्हाला काय कळलं नाही तर तुम्ही मला लगेच डिफिकल्टी विचारू शकता. ओके, सो हा क्वेश्चन घेण्याआधी मी 1 मिनिट पाहिजे तर थांबते. तुम्ही तुमचे कॅल्सी पाहिजे तर शोधा, जर तुमच्याकडे असतील तर नोटबुक शोधा, पेन शोधा आणि मग आपण हा न्यूमेरिकल स्टार्ट करू. सोपा न्यूमेरिकल एकदम, पण आपण 1 मिनिट थांबू. तुम्ही मला सांगा तुम्ही कॅल्सी आणले आणि मग आपण स्टार्ट करूया. किंवा मग आपण एक काम करू, it's already now 10:58, okay? Almost 1 hour we are going to complete. So I'll give you 5 minutes break. You keep your calci, pen and paper with you. Be ready. Okay, I'll give you 5 minutes break. After the break, you sit along with your all stationery. Fine for you? Yes or no?
Okay,
चालेल का?
ma'am.
Huh? Okay, fine. Okay, yeah.